video, we are going to look at a hypothesis test with a test statistic approach. So we'll have a look at the question, pull out our information. They tell us here we have 150 randomly selected cars. Record as they pass the checkpoint, that's fine. So the mean speed is 115. Standard deviation was 24 kilometers per hour. And then they tell us here the speed limit is 112. Okay, so part one, we're asked to test the hypothesis, 5% level of significance that the mean speed of the cars going by the checkpoint is greater than the speed limit. They want to state the null and alternative hypothesis and then give a conclusion in the context of the question. Okay, very first thing we'll do anyway is find our z-score, as in the test statistic. So formula in your log tables, no need to memorize. They tell us the mean speed of the cars is 115. Then the speed limit is 112. So we treat that essentially as the mean because we don't want them to go past that point or exceed it. Standard deviation of 4, and they told us there was 150 cars. So calculate our test statistic. It'll be 115 minus 112 over 24 divided by root 150 into your calculator. So you can put it in all as one, no need to simplify. 115 minus 112 over 24 divided by root 150 will give me back 1.530931089, which I'll tidy up to 2 decimals. 1.53. Okay, so I've gone and found my test statistic. So what happens now is we know our critical zone or critical region either sits between minus 1.96 and plus 1.96. So if it falls here, we're going to reject the null hypothesis. If it falls in here, then we fail to reject. So 1.53 would sit within this range. It's less than 1.96. So we fail to reject the null hypothesis. Now, what we would have needed to do at the start of the question is state your null hypothesis and alternative. So for our null hypothesis is that the mean speed is 112, and then that means for the alternative it's not equal to 112. Okay, so we've run our test statistic and we've rejected the null hypothesis. So to give a conclusion in the context of the question, we say we fail to reject the null hypothesis as there is not significant evidence to suggest that the mean speed of cars passing the checkpoint is greater than the speed limit. Okay, so that's part one done for 10 marks. Part two now, we're asked to find the p-value for the mean speed of cars passing the checkpoint, comment on what can be concluded from its value, and then a two-tailed hypothesis test at the 5% level of significance. That's fine. That's our process for a p-test anyway. So we're going to have p-value is equal to 2 times the probability that Z is greater than 1.53. So there's no need. Usually for a p-value I need my test statistic, but because I've calculated it here, I can simply just pull it down for part 2. Now, we know we don't calculate the probability that it's greater than 1.53. So it's 2 times 1 minus the probability that Z is less than 1.53. I'm going to go to my log tables. So that'll be 1 minus, we're looking for 1.5, come across to 0.03, we get 0.9370. Enter your calculator, 1 minus. Now, you don't need to simplify this much. Just for this example, I will. Get 0.063 multiplied by 2. We get 0.126. So what happens here is 0.126 is greater than 0.05. So we are not inside the critical region. So we fail to reject. HO. And then essentially you can copy and paste your comment above. There's no significant evidence to suggest the mean speed of cars passing the checkpoint is greater than the speed limit. Okay, so part 2 there done for 10 marks. You carried down a lot from part 1 in it, which is useful. Okay, and our last one then, find the smallest sample size for which the result could be regarded as significant. So we're back to test value, test statistic again. So we have our Z score. This time we won't know N. So for a result to be significant, we need to enter this area. So that means the modulus of Z has to be greater than 1.96 or equal to. Okay, so we let our Z value equal 1.96. Our X value is 115. The mean is 112. Standard deviation of 24. And N we don't know. So we have 1.96 will equal 115 minus 112. 115 minus 112 will give me 3 over 24 over root n. We don't divide a fraction by a fraction. We flip and multiply. So that's root n over 24. Now again, I'm oversimplifying a little here. But that's just to show the steps. Multiply across 1.96 multiplied by 24. And I can divide across by 3 as well. Will equal root n. Into your calculator. 1.96 multiplied by 24 divided by 3 give me 15.68 is equal to root n. Square both sides. The root and the square will cancel. Into your calculator, and we get n is equal to 245.8624. And we're going to round to the nearest number, so that's 246. So a quick way to test that would just be to sub back into your test statistic formula. So we would have 115 minus 112 over your standard deviation of 24 divided by root 246, which will give me back 1.9605 and so on, which is slightly above 1.96. So we would be in the critical region. So we'd be saying the result is significant. Okay, so that's that question done for 30 marks. Hypothesis testing using the test statistic approach.